Medium. Mix. Very good evening to everyone. Welcome to the second live interactive session for the course on Introduction to Aerospace Engineering Flight. So on the chat window, I will request the course TA Norman to confirm that I'm visible as well as my voice is audible. And then we will start the session. Actually, anyone can just enter, not necessarily the course TA. Anyone who is live with me can just let me know on the chat window that I am visible and the voice is audible. I will start once. Okay. Thank you so much. So one of the users has confirmed saying yes, sir. So I'm assuming that all is well. Today's agenda is as listed on the screen. As you know, in this course, there are 12 assignments which are being graded, weekly assignments. And most of you might know that 8 out of these 12 assignments are going to be considered in the final evaluation. So if someone has joined the course late, or if someone has missed a few assignments because of any reason, don't worry. So far, I think we have launched 8 assignments. There are 4 more assignments, and only best 8 out of these 12 are going to be considered. Remember that you have to individually clear the score or the minimum score in assignments as well as in the examination to be eligible for getting a certificate. So as I mentioned, even if you have missed a few assignments, don't bother. You can make up by giving the remaining assignments. In the last session held on 17th of August, I had spoken about NPTEL internship. I'll speak about it once again. Then there are a few questions from students from the announcement page, which the course TA has shared. I am going to try and give you the answers to those questions. And then I would like to once again talk to you about the discussion forum and its advantages for you as learners. I am told by the course TA that the discussion forum is not as active as it should be. So we will like you to participate more in the discussion forum. In the last session, I also mentioned to you about the upcoming NACDAC 7 event, but today I'll give you an update of that. It has been launched and you have time still to be a part of it. In the end, we will open the floor for any queries that you may have. So, in addition to the 12 assignments which are graded, I would like to offer to you an additional assignment which will not be graded, but which will make you feel very excited and motivated about this particular course. This assignment, which I am suggesting to you, is an optional assignment. That means if you wish to do it, you can do it. If you don't wish to do it, there is no problem. It does not affect your assignment score or your examination score. So this is purely for the joy of learning and experiencing. I have been running this course, Introduction to Aerospace Engineering, for our master's students and also a few undergraduate students in IIT Bombay for last many years. And as part of our evaluation, we normally do a series of assignments. One of the assignments which is very popular, very exciting, and many ex-students come back to me through email, through WhatsApp, or even when they visit IIT Bombay, they tell me that this is the exercise that they enjoyed the most in this particular course. That assignment, friends, I would like to showcase to you and urge you to do it in case you would like to really learn about flight and about aerospace engineering. And this assignment is about fabricating glider or gliders to meet some requirements. The requirements are very straightforward. The first requirement is, from any given point, we would like you to launch the glider with your own hands or using any launching device if you wish to make, so that it goes maximum distance along a straight line. A good aircraft is the one that is perfectly balanced and properly controlled. And here we would like you to incorporate features in the glider which minimize the deviation from the straight flight. So this is not about just the distance traveled, but distance traveled along a straight line. So any deviation left or right from the straight line from the launch point will be subtracted from the distance to call it as a range. This range is not the range that you see or study about in the aircraft design course for aircraft. Here we are looking at range as distance along a straight line. And the other thing that you can design for is to fly for maximum endurance, which is once it leaves your hand or if it leaves your launcher, how much time does it remain in the air before hitting the ground or before hitting any other object? That is the time in the air, and that is called as the endurance. Now, I would like to show you a small video in which these requirements will be explained, and you will see this exercise being conducted by about 12 interns who came and worked with me for a couple of months during the summer of 2017. So I'm going to stop the sharing of my screen, and I'm going to share the specific video. Okay, so let me share the correct video. Okay, so please help me. Yeah, it is this one, glider competition. Yeah. Hold it. Let us confirm that it is visible. Okay, so once again, I will request someone to confirm that you can see the screen, because I'm going to play a video of about 3 minutes and 45 seconds. Please confirm, and also please type and tell me what do you see on the screen. What do you see on the screen? Can you just type what you are reading on the screen? Very good. So I'm going to play the video now. So this is the definition of range, as I mentioned to you. The maximum lateral deviation from the straight line on the ground from directly below the launch point and bottom. We have done this exercise in a fire in our institute, which has got, you can see this is a big fire. And there you go. There is a central blue pillar. Our aim is to hit that pillar. And for the endurance, you can notice that so these are the 12 students who came as interns to work with me. They are holding their gliders in their hands. You can see it flies very well, but it is turning towards the left side. Once again, it flies level, but it goes towards the right side. So all these designs have been, this is a slightly better one, but it also starts deviating towards the end. Okay, so audio is not required actually. If there's no audio, then at least my audio should be there. So you can see this one is better. It has gone almost straight and hit the wall just on the right of the pillar. A good design, which again went and hit on the right of the pillar, 1.5 windows. It flies very fast, but deviates. Yes, Rohit, you are right. It will also depend upon how the person is throwing. Anyway, let me show you the results for the endurance. So here the aim was to have maximum time in the air. And you see the aircraft is going into beautiful circles. And ultimately about 13.6 seconds. Now you will see a design that hit the pillar. Okay, so now I'd like to know if there are any questions. So Rohit Bisht has a very good comment that it will also depend upon how the person throws. Yes, so you require practice and you require to try out various times before you get it right. Are there any other questions or queries regarding what you saw in the video? We will take them right away and then we will go ahead with the next point. Okay, so now let me again share with you another interesting document. which is regarding the trial for the best range in the next year. So you can see again. Now, this aircraft has gone a little bit deviated, but finally it has hit. So we don't have any means of finding the deviation. We are looking at the ultimate. So I'll show you once again. It goes to the left, but then it turns to the right and hits the pillar. Once you hit the pillar, it is fine. Actually, it is a bit unfair because it's a matter of fluke also. But then we say all is well that ends well. So if it goes and hits the pillar after deviating, it's fine. Let me now show you another video that is regarding the maximum endurance. This one show. You better not show. No, this one. Okay. So have a look at it. I'm going to show it to you 2 or 3 times. Yeah. So there you go. Here is a glider. You can see it is going to the left side, but then it is turning and hitting the pillar. Okay, I'll show it to you once again. It should be visible now. Now, you might call it fluke because it was deviating to the left-hand side and then ultimately, but it turned and it hit the pillar. So we will consider it as a success, even though it is not exactly on a straight line. So some amount of luck is also there. Let us see once again before we move to the next slide. All right. So now we will share this. Share there. Okay. All right. I'm going to now show you the flight for best endurance. So this is maximum time in the air. Watch. He's throwing it towards the left-hand side, right now intentionally. And he's fortunate that it did not hit any of the walls. And it went into circles and finally hit the ground. Okay. Once again. You can see the aircraft turns within the walls. And finally hits the ground. So this was the best endurance design. Okay, so I've shown you these two. So now I would like to tell you what is something I would like you to do. Okay, so I'll answer some queries which have come, but before that, let me just read them. Do we have double oblique swept glider? If you observe a dragonfly that has somehow shape of double oblique wings, Will it be beneficial if you make such wings? It will be beneficial, but it is very complicated to adjust between the two wings. And in Dragonfly, the flapping takes place with a particular frequency and also with some lag between the two wings. That is what gives it such beautiful flying features. If you are going to make a fixed wing with double oblique swept, you are essentially going to have 4 wings. You don't need too much lift, but there will be much more drag. So I don't know. It might be possible. It is up to you to make and try. Okay. So what I expect from you is this. Okay, you do it for me. I'll stop the screen. I'll
You have to first open the speaker.
yes.
Full screen.
Then make it full screen.
Now, what can now settings
Okay. So I would like you in your spare time to fabricate the gliders or more than one glider for maximizing range and endurance. Separate aircraft for each requirement is permitted, just like you saw my students have done. But what will be ideal is if you can have the same aircraft for both the requirements and you can adjust it or tweak it to meet both the requirements. So you first launch it for straight flight and then you maybe bring in a little bit of permanent or fixed yawing inclination and use it for long duration flight. That would be excellent if you can do both the requirements one by one in each different flight can be met using the same aircraft. To do this exercise, you will have to work indoors because if you work outdoors, you are going to be too much at the mercy of the wind conditions. So it should be preferably in an indoor fire. The fire that we have in IIT Bombay, where we do all our experiments, is about 60 feet high and 30 feet wide. So you can try to get a similar fire, any indoor fire. Many colleges do have such fires, or you may have some kind of a gymnasium or a sports area. You may have a badminton court or an indoor volleyball court, whatever you may have, any indoor facility where there is some altitude available, some height available for you to stand and launch your glider, and enough free area for the aircraft to fly without hitting any walls or obstructions. If you locate such a place, you can do your experiments there. What I would like you to do is record the flights for maximum range and maximum endurance. And notice, when you record these flights, the camera should not shake. The camera should be fixed so that the camera records the complete trajectory of the aircraft in one still frame. If you move the camera along with the aircraft, then there is no relative reference available. Okay, so we would like the camera to be fixed. You launch it and the camera should record the entire trajectory, either the trajectory for endurance or the trajectory for straight flight. And after you record these things, you can upload your videos with your name. So you can put your name underscore range and name underscore endurance like that. Upload it. You can also use your NPTEL registration number. If you don't want to put your name, you can put registration number underscore range and registration number underscore endurance. If you have more than one flight, which is very good, you can put _1, _2, but don't put too many of them. Upload the videos on a Google Drive and share the link with everybody in the discussion forum, not only with us. Let everybody else also see it. And then what we will do is, before we have the next interaction session in the month of October, the date is not yet fixed, but it will be a few days before your examination, approximately 25th October. Around that time, you will have the last and the session. In that session, we will showcase the best designs whose videos we get. And we will also announce your names in the forum. Okay. So if you have any questions regarding this assignment, I would like you to type out your questions on the chat window so that before I proceed further, I can try to sort out your doubts. Okay, I think the questions will come. In the meantime, I will continue to move ahead. While waiting for your questions or queries, I would like to touch upon once again the benefits of doing NPTEL internship. As you all are aware, NPTEL is a program of the Ministry of Education. And from 2018 onwards, NPTEL offers internships to the toppers of the various courses. This internship can be varying between 2 weeks to 8 weeks. And it's a paid internship. So you get a stipend of rupees 2,500 for 2 weeks internship and rupees 10,000 stipend for 8-week internship. In most cases, or in many cases, you do not have to physically come and work with the professor because there are issues of accommodation, expenses, etc. And this money is going to be not enough, especially if you want to come and work with me in Mumbai in our lab. The expenditure that you will incur about travel, accommodation, and food is going to be very high. People who are local, they might be having an advantage. But to be fair, it can be online, it can be offline, depending on mutual convenience. So NPTEL organization they ask the instructors, how many internships are you willing to offer and what duration? And then they send us the names and the details of the students who are in the top. Then we interview them, we talk to them, and then we offer internships. So please take advantage of these internships. Okay. There is a question from Shyam that the problems are not discussed in week 7 lectures. So Shyam, I'm not able to understand your query. Maybe you should put your query in the discussion forum and I will request the course TA to sort out. And maybe the course TA can explain what is meant by this query. I'm not able to figure out. I would like to seek your queries regarding the assignment which I have given. If you have any questions regarding the assignment, please ask them now. Otherwise, we'll just go ahead with our content. The internship that you do. So Nauman has mentioned that these are in-person internships, but Nauman, they can be online also. They can be in person. If someone wishes to physically relocate and come and work with the professor, it is possible, but it is not essential. They can also be online. It all depends upon the convenience of the instructor and the student who comes for internship. Nityam Bhagwat Sevaya says, good evening, sir. But I would like to know if you have any question, Nityam. So when you do an internship, you get a very nice certificate. And this certificate is verifiable because it will be available on the website of NPTEL. So in future, when you apply somewhere, you will be able to get this verified because anybody can go to the website and check. It will be available there. So it becomes a very nice, verifiable, formal internship. Okay, now we will take some questions from the announcement. Okay. So there is a question from Ifayani Godswill Ogbona. Are we going to have any physical class? So Ifayani, unfortunately, as per the best of my knowledge, there is no scope for any physical class under NPTEL. The only option you have is to interact with me like this in the interaction session. I don't think there is any option for any physical class under the NPTEL scheme. In fact, that is the whole purpose of NPTEL, that you can learn from a faculty member without necessarily interacting physically. Sarthak has a question regarding GATE exam in aerospace engineering. So he says that he is appearing for this examination for the first time, and he would like me to suggest books for preparation. So Sarthak, the first question I have is, you are giving or you are planning to give GATE examination in aerospace engineering. I hope your college degree is in aerospace engineering or aeronautical engineering, because many students from other branches like mechanical, electrical, civil, they have a wrong assumption that to do a master's in aerospace engineering, you have to give GATE in aerospace engineering. It is not needed. If you are, for example, a mechanical engineer, you can give GATE examination in mechanical engineering, which is what you have studied in your own college. And after getting a very good score in the GATE examination of mechanical engineering, you can take admission in MTech or aerospace. Similarly, if you are a civil engineer, you can give GATE exam in civil and then take admission in MTech aerospace in the area of aircraft structures or in fluid dynamics. If you are an electrical engineer or electrical and electronic communications engineer, instrumentation engineer, I'm not sure about the instrumentation engineering, but I guess it should be possible. You can give GATE in your own branch and then appear or apply for MTech in aerospace. So if Sarthak is there live, I would like him to type on the chat window what is his background, what is his discipline in the college, and then I can give you proper advice. But Sarthak, textbooks for GATE examinations, either they are already mentioned, I mean, any book that covers the syllabus should be good enough. It's very difficult for me to recommend any specific textbook because there are different books for different subjects. Broadly speaking, the GATE examination covers aerodynamics, propulsion, structures, and guidance and control, these 4 sub-disciplines. So there are different books for all of them. And there are also some books which are dedicated for preparing for the GATE examination. So please, you have to ask some of the seniors who have cleared the GATE examination. You can also consult your course TA, Namanuddin, because he has also cleared the examination last year and currently he is pursuing a master's program. So they are better guide or better informed and aware about which books are more suitable rather than me. So let's move ahead to the next question. There are two interesting questions. Rohit Bist, please tell the height from where the glider has to be dropped. Very good question, Rohit. In our case, we went to the third floor of the fire. Each floor is approximately about 10 meters. So it will be 30 meters. No, but sorry, wait a minute. It will be, each floor will be around 10 to 12 feet. So around 30 feet. So you can drop the glider from a height of around 30 feet. Okay. Of course, the higher you go, the better it is. Because the glider doesn't have any power plant. So it will continuously sink. So height will give you advantage. In our case, we have dropped it from the third floor of the fire. So the total height of the fire was 62 feet approximately. So I would say you can drop it from something like 50 feet height or 30 feet height. Okay. Any other questions if anybody has? We are very happy to take them on the discussion forum. And also in the chat window here. Prajesh Kumar Patel has a very interesting question. In week 6, we have discussed some coefficients. So Prajesh Kumar would like to know, in brief, why they are there, what they are, and why they are used. So those who recall the material from week 6 will remember that what he is referring to are the lift coefficient, drag coefficient, and moment coefficient for the aerofoil, which are called as C subscript L, C subscript D, and C subscript M respectively. And when we use aerofoil, then we use small case, C small l, C small d, C m small m. But when we define these coefficients for a three-dimensional object like a wing, which not only has an aerofoil cross-section, but also a wingspan, a finite wing span, then the coefficients are called as C capital L, C capital D, and C capital M for the wing. So these are the 6 coefficients, 3 for the two-dimensional case for the aerofoil, and 3 for the three-dimensional case, which is the wing. Now, the question is, why are these coefficients there? These coefficients are there to allow you to compare the aerodynamics of two bodies which have different size, different shape, and different orientation with each other. The reason for this is very straightforward, that the amount of aerodynamic force perpendicular to the relative wind, which is called as the lift, or the amount of force acting on the body along the relative wing direction, or the moment about the quarter chord, the aerodynamic moment Cm. They are all dependent on certain factors and certain parameters. They depend on size. If you have the same shape and if you make the size larger, if you increase the area by 2 times, you will get more lift. You will get double the lift, everything else remaining same. If you have higher relative velocity, you will get much more lift and much more drag. In fact, it is proportional to V square. If you have a different shape, you will have a different characteristics. And if you also have different orientation, which is called as the angle of attack, all of these make a difference. So therefore, what we do is we define these coefficients. So by incorporating the effect of density, area, compressibility, and speed on the lift, drag, and moment generated by a body, we define these coefficients. So for the wing or for any 3D object, we generally define lift coefficient CL as the lift produced non-dimensionalized by half rho V square, which represents dynamic pressure, into area. Now this area is the reference area. Okay, generally it is the wing reference area. For an aircraft, it is a wing reference area. But if you have a body of revolution like an airship envelope, then we don't use area, we use volume power 2 by 3, which is a surrogate for area, because volume power 2 by 3 will have units of meter square. And that is what is needed to make the equation non-dimensional. Similarly, we define CD, the drag coefficient, as the drag produced over the body, by the body, upon dynamic pressure into reference area. And similarly, the moment coefficient is defined as the moment created in Newton meters divided by dynamic pressure into wing reference area into the mean aerodynamic chord. So by doing this, we come across three non-dimensional coefficients which capture the effect of various factors that influence the creation of the lift, drag forces, and the moment. So I hope it is now clear to you why we define these coefficients, how we define them, and why they are used. Rajesh Kumar, if you are in the meeting, you can please confirm in the chat window that you are now clear and your question has been answered. Rajesh Kumar has one more very interesting question. His question is, how does the bypass air in a gas turbine engine accelerate? What element of engine is responsible for accelerating bypass air? Okay. So basically the question is that when you have a bypass duct in a gas turbine engine, how does the bypass air accelerate? Which element of the engine is responsible for providing the acceleration to this bypass air? So to answer this question, I would like to show you this animated GIF file. First, I would like someone, preferably Norman, to confirm that the GIF file is visible. Once I get your confirmation, I will proceed further. Okay. So in this particular GIF file, you see multiple colors. This is a two-spool or double-spool bypass turbofan engine. So the low spool is shown in yellow color, and I'm sorry, the low spool is shown in, the yellow color, I'm right. And the turquoise color shows so the high speed, the high speed spool is shown in the yellow color, and the low speed spool is shown in the blue color. We can see in the GIF that the low speed, the blue or turquoise colored items in this particular GIF file are rotating at a lower speed compared to the yellow colored files. Also look at the arrows. You can see that the arrows change their color when they go through the high pressure compressor and the high pressure turbine in the combustion chamber. So as the air passes through the compressor, it is being compressed, so it starts getting heated up. But when it goes through the turbine, there is a huge amount of heat addition, so it becomes hot. And that hot air is then thrown out to drive the low pressure turbine. So interestingly, the high pressure turbine that is shown in number 6, that drives the low pressure compressor shown in number 3. And attached to that is a huge fan, which is shown in number 2 here. So that fan is the one that really pushes the air. Okay. So the answer to the question by Prajesh Kumar Patel is that it is the low speed fan attached to the low pressure compressor, which, like a propeller, provides some momentum to the air. The acceleration actually takes place in the nozzle of the fan, which is shown at number 9. You can see the shape of the nozzle there. So the acceleration of the air actually takes place in the nozzle, but the fan is pushing it by imparting momentum. The fan is attached to the low pressure compressor, which is driven by the low pressure turbine. Okay, discussion forum, all of you know, we just want to say that unfortunately the forum is not very active, and we would urge you to please use it to your benefit actively. I will skip this particular slide about NACDAC because I think I've shown it to you last time. I'll go very quickly. You know about NACDAC. I think I have mentioned last time. It's the 7th edition of a National Aircraft Conceptual Design Competition. So we conducted completely online till the final round. We encourage teams of students, maximum 5 students per team, but we insist 2 members of the team should be from aerospace engineering. And only 1 team per institution. And we also request 1 faculty mentor. There are 3 rounds. There is an initial conceptual report. Then there is a midterm design report, final design report, and then If you are among the top 5 teams shortlisted, you will you'll be invited to Bangalore for the final presentation round. The total prize money for NACDAC currently is rupees 45,000, but it changes depending on addition of new sponsors. And all students who reach the second stage and submit the final design report, they are given a participation certificate. So we'll skip this because we don't have too much time today. We will just open the floor for any queries because we have only about 5 minutes remaining. So I thought it's important to have some time for your queries. So Prajesh Patel has asked a question about mechanical work done by the bypass air, which is true because the bypass air is not doing anything. It is just being pushed by the fan and it is going through the nozzle and generating some thrust there. So the floor is open for any queries that you may have. We have only a few minutes remaining. And in these few minutes, we will take your queries. So if there are no more questions, then I think we can stop this session. Yeah, mechanical work is done on the bypass air. That's a different thing. But my comment in the lecture probably was that the bypass air itself does not do anything. Harsh has a question. What if the student is busy with college work and is interested to learn and also, but didn't as sort of time? Well, it's a tough question. If you are interested to learn, you have to find time. You have to cut down on some other activities which you do to waste your time and use that time to devote attention towards the activity that you like. That's all I can say, because all of us have the same 24 hours a day that you have. But those people who are able to do many wonderful things in those 24 hours, they do it because they are focused in what they do. And there are other people who are wasting many, many hours in a day in activities that don't add any value to your life. I know it is tough, but you got to find time and you need to prioritize. Ishant has a question. How and why SFC varies differently for different aircraft depending on speed? No, it's not about aircraft. It's actually, SFC is a function of only the aircraft engine. Aircraft engine. Different engines have different schemes for producing thrust, and they are affected differently by the conditions, atmospheric conditions, as well as the operating conditions. So the SFC of an aircraft is a function of SFC of the engine. In fact, we never say aircraft efficiency, we always say engine efficiency, because it is a term which is directly and totally related to only the performance or the efficiency of the engine. Okay. For example, in case of a turbo fan engine or turbojet engine, The SFC is the thrust produced by the engine. Okay. Fuel flow of the engine divided by thrust divided by time. So there is nothing to do with the aircraft in that. So they vary because of the difference in the effect on their performance and the thrust produced, or the fuel flow with the operating conditions, temperature, pressure, ambient air density. All of these affect differently. So the formulae that we have given are only indicative formulae. Those are approximate formulas which have been obtained by fitting some curves with the performance predicted by various engines. They are not perfect and they are not very correct, but they are good approximations. Okay, so on that note, I think I need to stop because I have another session which is going to happen in the next few minutes. So therefore, I would like to say goodbye to you, and I would like to request you to take part in discussion forum, utilize the facilities available, and prepare well for the course. And I'll see you again in the third and the last interaction session. Thank you so much.